The Passy-Muir tracheostomy and ventilator swallowing and speaking valves incorporate a unique patented design feature that translates into significant benefits which are exclusive to the biased closed position no-leak design. To understand the principle behind the Passy-Muir patented feature, it is important to first understand how an open position valve operates. An open position valve uses a membrane or diaphragm to perform the valve opening and closing functions. The membrane flexes during inhalation, which allows air to pass around it and through the tracheostomy tube. When the inhalation cycle reaches its peak, the membrane temporarily relaxes and returns to its normal position. At this point, the valve is not actually closed. Reversed airflow, which is produced by exhaling, is necessary to force the membrane against the valve body to produce a seal. Before the membrane actually closes, there is a short time lapse where some exhaled air can escape. In addition, some common breathing patterns create an airflow phenomenon that can cause the membrane to vibrate or oscillate, which prevents it from completely sealing, resulting in noise as air leaks out. The open position valve allows secretions to travel up the tracheostomy tube and potentially occlude the tracheostomy tube in the valve. The Passy-Muir valve has a patented feature that virtually eliminates the possibility of these kinds of problems. This feature creates a closed position, no-leak condition. The membrane's outer perimeter is forced to normally be in a state of compression against a lip inside the valve body. In a relaxed state, the valve is completely sealed, not requiring reversed airflow to close it. When inhalation begins, the membrane easily bends out of the way to allow air passage with minimal resistance. When the inhalation cycle reaches its peak, air stops flowing and the membrane instantly returns to its normal fully sealed position. This is the closed position no-leak feature. As exhalation begins, the valve is already closed, and air immediately follows the path of least resistance up through the trachea and past the vocal folds, exiting through the nasal cavity and mouth. Because the valve closes at peak inhalation, a column of air remains in the tracheostomy tube at all times, creating resistance to secretions entering the tracheostomy tube and the valve.